My name is Christian Garcia, and this is my presentation on Project 2. The project was to find a freely vibrating structure, and I chose to use a ruler vibrating back and forth. This is a quick demonstration on the project that I conducted, and I used Tracker to track the displacement over time of that ruler vibrating back and forth. And there are some gaps within the data on moments where Tracker had difficulty tracking, but for the most part I was able to get the graph. And then using the experimental data, I calculated the damping coefficient. Then using the theory on structural continuous systems, I found the equation of motion, first by identifying the vibrating system, creating into a vibrations model, then a free body diagram, and finding each coefficient for the equation of motion. And then with that, I was able to turn it into a second order ODE and solve it to find an equation that I could graph. And with that previous equation, I was able to graph it and find a theoretical graph, which looks very similar to the experimental graph. Then I put the theoretical and the experimental data on the same plot and found that they were similar but slightly different, with the experimental being bigger than the theoretical. And I believe some reasons for these discrepancies are outside factors such as air resistance and gravity, as well as my personal placement of my camera when conducting the experiment. I believe I didn't have it fully horizontal, so it could have caused some discrepancy with Tracker. But overall, I enjoyed this project and I found it interesting, and it helped me better understand how vibrating structures work and how damping affects vibrating structures.